Oh, hi there. Thanks so much for showing up here in Math Learning. It's Tutor Grant, and we are looking at question 25 from the Pascal. Ooh, I better get a pen out. We're looking at question 25 of the Pascal 2019. So read the question and just see all of this algebra. Isn't it beautiful? So much algebra. Okay, so PUW. This bit here is has area 4x plus 4. All right. SUW has area 2x plus 20. Okay. Area of SVW is 5x plus 20. Okay. SVR is 5x plus 11. QVR is 8x plus 32. And QVW is 8x plus 50. How are we supposed to find the area of that? I don't know what it is, so let's call it y. All right? Y equals is what we're looking for. So how the heck can we do that?
How the heck, Dad? Oh.
Yeah, how the heck? Well, first of all, wouldn't it be really useful if they just told us the area of those different triangle sections? Man, we can figure it out, okay? We can figure it out for this reason, all right? I'm going to show you the way that we can do it. Okay, I'm going to call this B1, that's this length here. And then B2 is this length over there, B2, okay? And then this is H1, and then this is H2. All right? So, what we've got are 4 different triangles, and like if we do like a ratio of these two triangles, it's going to be the same as the ratio of those two triangles. You see, because these two triangles have the same height, and these two triangles have the same height. And these two share that base, and these two share that base. So we do ratios of those triangles. And this is what it's going to look like. I'm going to make that blue, and then I've got 8x plus 32 divided by its friend up above, 8x plus 50. That should be the same thing as this one divided by its friend up above. Okay, so that would be 5x plus 11 divided by 5x plus 20. This is pretty gnarly, folks, because here's how you're going to solve these, okay? Do not dare and cancel away your 8x's and your 5x's, because then you find 32 over 50 is the same thing as 11 over 20, but of course it isn't. It's not, because the x's don't cancel. There's one and only one value of x that makes that statement true. And we find it by multiplying both sides by 5x plus 20. Okay, so we're going to multiply both sides by 5x plus 20. Oh, wait, on this side, whatever x is going to cancel that down there. All right, so I can do the same thing with the other denominator. Multiply both sides by 8x plus 50. Okay, multiply this one 8x plus 50. Okay, and let's put these in brackets. Oh, look, this cancels over here, like that. All right, put these in brackets as well. So now we're going to do binomial times binomial on both sides. Yeah, this is pretty sophisticated for grade 9s. All right, so we now have 5x times 8x over here gives us 40x squared. 5x times 32 gives us 160x. 20 times 8x gives us 160x. And 20 times 32 gives us 640. Equaling, well, over here we've got 5x times 8x is, oh good, 40x squared. 5x times 50 is plus 250x. 11 times 8 is plus 88x. And 11 times 50 is plus 550. Okay, so simplifying, the first thing that you would do simplifying this is say, I'm going to subtract 40x from both sides, sorry, 40x squared. All right, and then combine the rest of my like terms so that I get 320x plus 640 equals 250 plus 88 is 338, right? 338x plus 550. Okay, we're getting close. We just now have to subtract 320x from both sides to get x's in one spot, and then subtract 550 to move the numbers to the other side. Then we have this beauty equation, 90 equals 18x. Finally. And you're like, okay, finally we've solved the problem? No, you wish. You wish this is solved now. All we've done is solve for the value of x, which is 5. Okay, so 5 equals x. All right? Now we can find the area of all of these spaces. Okay, so let's go ahead and do all the spaces. I'm going to erase all the things. Oh, but I should leave them up while I do this. Okay, so just erase all my notes, all my bits, okay? And PUW is 4x plus 4. Well, that's 24, okay? SUW is 2x plus 20. Well, that's 30, okay? 5x plus 20 is going to be 45. Okay. 5x plus 11 is 36. Okay. 8x plus 32 is 72. And 8x plus 50 is 90. So once we solve for x, we could find the actual like integer value for the area of all of these triangles. I know, right? Isn't it crazy? Isn't that just wild? Okay. So now what we need to do is show that QV is twice as long as VS. All right? So if QV is twice as long as VS, how do we show that? Well, this is twice as big as that. This is twice as big as that. But because both of these triangles have the same like height here or height here, then that means QV is twice VS. Okay? So if QV is twice VS, we also don't know that area QWT, so let's call that Z, because we've already got a Y, so we'll call this Z. Okay? So QV equals 2 times VS. All right? So that's true. And now that also means that a triangle RPQ is equal to 2 times the area of triangle RPS. But area RPS is, let's just zoom out a little bit so we can see all the things. So that's equal to 2 times 24 plus 30 plus 45 plus 36. Okay? So 2 times that, well, that's, we add all those up. 36 plus 24 is 60. We got 90, 45, that's 2 times 135. So that's equal to 270. Okay? So 270 is the area of RPQ, but RPQ is equal to Y plus Z plus 90 plus 72. 90 plus 72 is 162. Okay, so we can do Y plus Z plus 162 is equal to 270. Then we subtract 162 from both sides to find that Y plus Z equals 108. We're getting closer, but we're still not sure how big that is. Okay? So now we need to observe something. Whew. What are we going to observe, folks? Well, give me a second. I need to look at this. I'm a little lost. Just let me look. Okay. One last thing that we're going to look at here is, so we now know y plus z is, this is equal to 108, right? 108 is y plus z. Okay, but we'd like the ratio of y to z. And we can get it if we notice that like WT is a ratio to like this one here. Okay, so WT its ratio to WS is going to be the same as, well, this one. That's the triangle formed by WS to height Q, all right, which would still be our height there. Okay, so WS down there, that triangle, it's 135, and that would be the same as the ratio to Z. Okay, so this triangle here, this is like B1, this is B2, and they both have the same height, all right, because those are collinear, so that's working. But then we can form that same ratio, WT to WS, this way, with Y on top of 54. All right, now this will simplify to, well, we'll just take out the middle bit. Z to 135 equals Y to 54. All right, now if we cross multiply those, or just multiply, you know, we get you know, let's multiply both sides by 27. Okay, so both those things have factor 27 in them. So then we get Z on 5 equals Y on 2. Or in other words, just working horizontally here, 2Z equals 5Y. There's the ratio between Z and Y. That's how they divide up the area 108. All right, so let's go find some blank space. 2Z plus 5Y. So if we have 2Z equals 5Y and Y plus Z equals 108, this is two variables, two unknowns. We finally have a system of equations we can solve. So let's go, Z is equal to 108 minus Y, and we're going to put that over here to solve for the value of Y. Okay, so we've got 2 times 108 minus Y is equal to 5Y. Or, now we have 216 minus 2Y equals 5Y. Or, 216 is equal to 7Y. And then when I divide both sides by 7, folks, we find that this is 210 plus 6 all over 7 is equal to Y. In other words, Y is equal to 30 and 6/7. That's the area of that little bit we didn't know. We were asked for the closest integer, so 31 would be the correct answer. Any questions, hit me up in the chat. I find these like, wow. To be honest, this is where I got to without help, was I got to this part and I can solve that, no problem. But then I thought, well, it's just double on the other side, right? Like this doubles this and that doubles that. So that should be 60 and this should be 48, right? And together they add up to 108. But no, of course it doesn't. It's never that simple. We need to still work with that idea of triangles. These don't share like a height in the same way that these ones share a height, right? So it's not divided up evenly because it's angling down this bit here. So I really needed some help with the solution, and I enjoyed doing this problem a lot, so I think I'm going to be much better prepared to deal with funky triangles like this in the future. The algebra wasn't that scary. It was working with the triangles once I had solved for x. So I learned a lot from this problem, and I don't think I would have gotten it on my own without having looked at the solution. I would have been frustrated. All right. So thanks so much for showing up for your learning. I learned a lot. I hope you did too. And I look forward to seeing you at the next Maths Mastery League. Bye for now, everybody.